Okay, in this problem, we have three blocks. They're being pushed across a horizontal frictionless surface by some horizontal force F prime that's given. The masses of the blocks are given as shown, and we are being asked to determine the normal forces between the blocks. So the blocks are exerting forces on each other, and where that happens is that happens at the interfaces where they have contact. So I have contact between the two M and M block right there to the left of the M block, and then contact between the M and 3M block as well. So what this question is asking us is to determine what the forces are at those interfaces. So we start, as always, by drawing our free body diagrams. In this case here, because we know that the applied force is to the right and we know there's no friction, this is horizontal, one thing we can know is that the entire system is accelerating to the right. So if it helps you to put that on your diagram, our brains love pictures. So the more pictures you can draw, the better. I know, oh, that wasn't given as A prime, that the acceleration is to the right. And what that is going to do is going to influence my choice of sign convention here. So because acceleration is to the right, and I know that for this problem, it's often beneficial to have positive in the direction of acceleration if you can swing it. So I am going to go ahead and have positive be to the right for my analysis. Okay, so I will draw my free body diagrams. Free body diagram for the 2M block here, the M block, and the 3M block. And then we'll go from there. So hopefully at this point you've gotten more comfortable with drawing these. It's not enough just to watch me draw them. You like anything else, in order to be able to do it yourself, you need to practice it yourself. So be sure that you're doing that. The 2M block, I can look and ask myself, what are the forces on that? The 2M block is the one that is in contact with this force F prime. Notice that F prime is not touching M, it's not touching 3M, it's only touching the 2M block. So because it's in contact there, we can only write down what's actually touching the block apart from weight. So F prime is going to be directed to the right for this block. What else is touching it? Well, I have the interface between 2M and M that's in contact there. So that interface will be pushing left. The M block will be pushing left on the 2M block. That's a normal force. I'll call that N12. And that's going to be at the interface between blocks M and 2M. I'm going to go ahead and highlight that. I want to try to use colors to keep track of this. So this normal force 1, 2 is referring to the interface between blocks 1 and 2, or the block M and 2M there. Other forces on the 2M block, no other forces that we're going to use in our analysis, but I mean, technically its weight is definitely downward 2 mg. That's our one invisible force. And then the surface beneath it that's also in contact with that 2M block, right? That's exerting an upward force on it. And I'll call that N sub 2 there. Okay. And I'm not going to be doing any vertical analysis, so I'm not going to put a ton of time into doing that. I'm only doing horizontal analysis. Oh, and I want to put my sign convention on my free body diagram. That reminds me, when I'm summing my forces, reminds me what my signs should look like. So now I'll go to the block, the M block. What's in contact with that? Well, it's in contact with the 2M block, but now that force N12 is directed to the right. So I have directed to the right, N12. And if I were to highlight that, that would be also highlighted in this orange color as it relates to the interface between blocks M and 2M. So other forces on this block M, well, what else is it touching? It's also touching the 3M block, yeah? So the 3M block is pushing to the left on the 2M block, and I'm going to call that N sub 1, 3, because that is the interface between block 1 and block 3 there. And I'll highlight that with a different color. Use green there for N13 right there. And I'm noticing that the notation that I'm using as I'm writing this solution is slightly different from the notation in the written solution. So in some ways that's good. You don't let the notation throw you that much. Pick which you can pick a notation that you like better and stick with that, I guess. I'll be consistent throughout each example, however. Okay, other forces on M. Well, we have its weight, and then there's a normal force from the substrate below there, the horizontal surface that's upward. I'm just going to call this normal one. Again, we're not going to be utilizing any of the vertical stuff, and rightward is still positive for this guy. 3M block, what's touching the 3M block? Well, it's in contact with the M block, so there's a force to the right. I'm going to call that normal force 1 sub 1 3. So this, if I were to stay consistent here, this is going to be green as it relates to the interface between the M and 3M block. So that's touching it. What else is in contact with this 3M block? The surface underneath it, exerting an upward normal force, again, that we're not analyzing. There's no acceleration in the vertical. We're not doing any vertical analysis here. And then we have downward the weight of the 3M block. Its magnitude would be equal to 3mg. Rightward, also positive here. So those are my forces. Now I can write my Newton's second law statement for each of these using the sign convention that I've applied. So for the 2m block, I would get F prime minus N12 is equal to the mass 2m multiplied by acceleration A. I don't know what that acceleration is, but I got to call it something. Block M, same thing here, N12 minus N13, considering my sign convention there. I'm only looking at horizontal forces here. It's equal to the mass M acceleration. Again, the accelerations are positive. I made that happen by choosing positive in the direction of acceleration. So when you get to the right-hand side of Newton's second law, you do need to consider sign too. Sometimes folks forget that. They think about signs when they're summing their forces and they're all analytical there, and then they just throw an MA on the end after the equal sign on the right-hand side of their equation. But you should always be thinking directionally there too. Acceleration is a vector. So the 3M block, N13, that's all I got here in the horizontal, is equal to the mass here, which is 3m acceleration. Now I've made all the accelerations the same symbol, A, because these three blocks will be traveling together, so their accelerations will be equivalent. Okay, so I've got three equations here. I can pause and ask myself, what are my unknowns for this problem? Before I move on, make sure that I'm good to go here. So what's not given? The normal forces, N12 isn't given. Um, N13 isn't given, and acceleration isn't given. Everything else, though, if I look at the other symbols in my equations, they're given the m's. I know masses and I know F prime. So I've got three unknowns and I have three equations. So that is great. We're good to go. Do a little algebra here in order to find the normal forces in between your blocks. And what we should end up with here is for N13, 3m oh no, I'm not done, sorry. For N13, take that back. We should end up with F prime over 2. So that will be the force in between blocks M and 3m. And for normal force 1, 2, between the other two blocks, we should get, between blocks 1 and 2 there, we should get 2F prime over 3. So, regardless of your algebraic process, there you can use substitution, simultaneous equations, whatever floats your boat. But we should all agree in the end at what we get for the normal forces.